Hey, what's up, guys? This is Sheng here. So today, let's take a look at this LeetCode problem 1094, carpooling. Uh, Medium level problem. I think it's not that hard, but it's I think it's worth sharing with you guys a few solutions, different solutions for this problem. Okay, so you're driving like a vehicle that has a empty seats empty seats initially available for passengers. And the vehicles only drives east, which means it's going from left to right. Okay. And you're given like a list of trips. So the trips has three elements. The first one is the number of passengers, okay, that this trip will carry. And the second one is start location. The third one is end location. Okay. And then there's another like a capacity here. Okay. So it asks you to check if you can finish the whole trips with the current capacity, which means at any given time the car cannot take more than this capacity number of passengers. If that happens, we simply return false. That's exactly what happened in the example one here, because at location one here, right? We pick up two passengers, but at location three here, we picked another three here. Okay, and the total is five, which is like exceeds our capacity. That's why we return false here. And the second example is like it's five I mean because the two plus three is five. It's not exceeding the capacity. Okay. Same thing here, right? So that's the third example is because basically, since we start at five here, right, and then at the location five here, we have already dropped off these two passengers. Okay, so from here, I think probably you guys already know that, right? I mean, this is a kind of like a sorting problem, right? Because you know, so the trip length is this. Okay, so we have some constraints here. So the first intuition will be like we should sort by the start time, right? By the start time and then the end time. That way, basically, every time when we have a start time, we can simply um, remove, right? We can certainly remove everything. Uh, we can remove everything that's previously like ending time, whose ending time is smaller than the current start time. Okay. To do that, we can simply use a priority queue. Okay. So for the priority queue, we every time when we see like a new trip here, right? We first we try to everything that's pop all the trips that finished before this new start time. Okay, and then in the end we add this like new start time. And meanwhile, every for loop we just check if the total is like exceeding the capacity. And if that's the case, we simply just return the false. Otherwise, in the end, we return true. Okay, so I mean that's the first approach, right? I mean that approach is not. I think it's the n log n, right? Because at the beginning we need to sort. We sort it, and then every time when we have like and then later on we have a for loop, which is the n, and then every time we do a heap push and a heap pop, and for that is a log n. So in total it's n log n. Um, You know what? Actually, let me try to implement that real quick. So actually today including this one, I'm gonna try to show you guys three solutions here. Okay, so we're gonna have like a hmm. So first, I'm going to sort the current one. Okay, the key is lambda, right? Since we're going to sort by the second and the third elements here, I'm gonna do a like x1 and then x2. Basically, I'm creating a customized sorting key, which is a tuple with the second and the third element here. Okay, and I have a priority queue here. Okay, so basically this is what I mean. Basically for like number, right? And then I have a like total here. Okay, so for number and the start and the end in the trips. Okay, so at the beginning I will try to basically pop everything in the priority queue. Okay, basically in the priority queue here I'm gonna store two values here. So the first one is the ending time, and the second one is the number. Okay, because I need to use the ending time to help me to pop everything. Okay, in here. So basically, while the priority queue is not empty and the the priority queue dot zero is equal or smaller than the current start. Okay, if that's the case, I simply just do a pop. Okay, we do a heap pop. Okay, do a heap pop priority queue, and then actually heap queue dot heap pop. Okay, and then I'm gonna need to remove this total numbers. Okay, because after popping we have end time and numbers here, right? And then we have this one. The second one is the total numbers. Okay, now the total number is equal. Now we add this one here. Now we'll do a like heap push. Okay, heap queue dot heap push the priority queue, and here we're gonna have like the new end, right? The new end and the number. Okay, so and also we need to add the current total with the current number here. If the total is greater than the capacity, okay, then we simply return false. Okay, later on we return true here. Okay, I think this should work. Oh, sorry, 0. Okay, all right, submit. Cool. So this first one it works, right? Because I mean the time complexity is here's a the first here's the unlock n. Okay, and here this is the n, right? And the heap pop and push here here we're gonna do like n of the hmm. Actually, the worst case scenario for this one here is gonna be I mean yeah, this is fine because here I mean the total number we're gonna do the pop will be n. So basically here is also log n here, and here is also log n. So in total, this part is also n log n. Okay, yeah, we're not doing this like pop n times every time because the total times will be n. So when it's gonna allocate it, so when it comes to the amortized complexity, so this one is like O1 here. This one is O1. So which means here is just a log n. Okay. Okay, cool. So this one is pretty easy to understand, right? Basically, every time when we have we sort, and then every time we have a new start, we pop everything that ends before the start. Okay, and meanwhile, we're also maintaining like total number, total passengers. Okay, cool. So that's the first one, and the second one. So the second solution is that every time when you guys see this you have like a few bunch of like a point here, like timestamp, or in this case, it's like the location, a bunch of locations here, and you either have like a start. It's basically like a start point and end point, okay? And then basically at each of the location here, right? You have like at the start locations, you basically you increase the passengers by 2, and when you're at this like the end location, basically you decrease the passengers by 2. Okay, so for this kind of problems, you can basically you can separate the start and end. You separate them into 2 events. Okay, and then in the end, basically you just spread them into like into this like 1D lines here with the start and end time. And at start time, you increase this number, and at the end time you decrease. And then in the end, you simply scan those like the locations from left to right. And then every time when you see, as long as by the time you see the number that's greater than the capacities, and then you return false. Okay. Mm, okay. So we're gonna have locations. Okay, locations like this. Uh, locations. So the locations. Okay, let me see here. Okay, so this is what I mean here. So basically for like again for the numbers start and end in the trips. Okay. Uh, locations. Okay, locations dot append. So the start is the number. Okay, and then locations dot append end is the negative number. Okay, so how about the duplicate locations? And I mean the duplicate locations doesn't really matter, right? Because we are in the end we'll be sorting by the times that by the locations anyway. So we can simply like basically append each event to these locations, and later on we just need to do a sort basically. We just do a sorts by by the location, right? So and then like for uh location and then the numbers, okay, in the locations, we need to have a total, okay, again. So total plus number, okay, and if the total is greater than the capacity, and then we return false, okay, else we return true. Okay, so this should just also work. Cool. I mean, so as you guys can see, this thing is, I think it's a little bit faster than the other ones because we don't need to do like the heap thing. So we just do a for loop here. This is n, right? So this is n, and here the sorting is n log n, and here it's just another n here. Okay. I mean, this is a better solution because so for this one, I mean, I think for you guys, you just need to, I mean, have this kind of idea in mind that every time when you have like this start and end things, you can, and especially, when it asks you to calculate the total numbers, the total like values like that happens after a few of events, right? In that case, you just need to basically separate those events into two events so that you can later on you can scan it from left to right because this is important. You need to sort it. Okay. Okay, so that's that. And the third one, can we further improve this one to a even faster solutions? It depends. Okay. So this is where we need to like improve. So why is that? I mean, because the reason we're doing the sortings here is because the locations we don't know the locations, right? We don't know the range of the locations. That's why we need to sort it because the locations could be from anywhere to anywhere. But but here there's a like interesting like constraints here. So the trip's length is one sorry here number four here. So the location start and end they are within the range of 1,000. So which means that I mean the total length of the location is from 0 to 1,000. Okay. Then with this range, right? I think some of you have already realized that we can use like this bucket sorting thing, right? Sorry. Basically, we create like a bucket, right, for each of the locations beforehand, and then we do the same thing here. Okay. Basically, we put each of the location into its bucket. Okay, and since it's already sorted, it's already like in the sorting sequence, right, from 0 to 1,000, we can just simply remove this part. Yeah, cool. So real quick, I mean, I think it's pretty similar with the above one. Basically, we have locations, right? Um, at the beginning, everything is 1,000, 1,000, I think 1,001. Okay, and then I just basically copy everything here. I just copy it here, but instead I'm removing this. Okay, and here. Okay, I can simply okay, sorry. So actually the key will be this the events here. Okay. Okay, so that's that. All right. And the value the other thing is this, right? N equals to minus n here. Okay, so after that, right? After that, we just need to scan from the left to the right because if there's nothing there, the value will be zero, so it will not affect our total. Okay. Yeah. So submit. Oops. Uh. Oh, sorry. Uh. Increase. Okay. Because be at this one for this one here, since we're appending, so basically if the location is the same, it doesn't really matter. We're gonna have like two events of that, and later on we'll be accumulate everything together. But right now, since we're using a bucket, right? So each of the bucket holds everything for this location. So that's why we have to accumulate that. Okay, and this should just work. Cool. Yeah, I mean, I think that's it for this problem. I mean, it's a pretty standard problem. It's not that hard, but I think it's worth sharing with you guys like the different like ideas or different intuitions to come up with the solutions, right? I mean, the first one, I mean, it's okay, right? The second one is you need a little bit of like a previous prior experience, like the how can you separate this events, right, into two separate events so that you can sort it and then you can just scan it. And then the last one is even a little bit more a little bit trickier because you need to realize that these constraints here, which means that you can trade like some extra you can trade the better performance with some extra like uh space here. Okay. And the last one, as you guys can see, it's a ON solution, right? Because here's just ON, and here's also ON, but with a little bit of extra, a bit more space here. And cool. I think that's that's all I want to talk about for this problem. Thank you so much for watching the videos, guys. Stay tuned. Bye bye.